Now you will learn about maps. A map contains associations between objects called keys and objects called values. So for example, we could have ABC associated with 5.7 and then QWE associated with 9.5 and then DEF associated with 8.6 and ASD associated with, say, 3.4. That would be an example of a mapping. Now, we cannot have duplicate keys, which are the elements on the left side. So like if we had something like ABC goes to 1.2, that would be not allowed. ABC goes to 5.7, that would also be not allowed, because we have a duplicate ABC here. However, having duplicate values is allowed, so say have ZXC goes to 5.7 is allowed, because even though the 5.7 is the same, ZXC is different from any of these, so therefore it's allowed. Now you'll learn about hash maps. A hash map is an unordered map, and just like the hash set and tree set, you must import it, so I'll just do this by import java.util.star, and it has the following methods. So first, there's size, which returns number of mappings in the map. Put, which maps a key to a value, and if the key is already mapped to a value, it just overrides the mapping. There's get, which gets the value a key is mapped to, or null if it doesn't exist. And there's contains key, which returns a boolean indicating whether the key is mapped to a value or not. Contains value, which returns whether the map has the value. And then put if absent, which maps the key to the value if the key is not already mapped to a value. There's remove, which removes a mapping from a key, and remove with two parameters, which removes the mapping from the key to a value if the key is mapped to the value. And then replace, which maps the key to the value if there is already a mapping. And then there's entry set, which returns a set of map.entry or pairs of keys and values. And there's key set, which returns a set of the keys in the map. And finally, values, which returns a collection of the values in the map. Now let's show you an example. So let's use the example up there, hash map from string to double. Let's put ABC to 5.7, put QWE to 9.5, put DEF to 8.6, put ASD to 3.4, put ABC to 1.2, and then put ZXC to 5.7. And now let's print the map. And it'll print ABC goes to 1.2 because although ABC was originally mapped to 5.7, this mapping overwrote that mapping, so now ABC is mapped to 1.2. ASD is mapped to 3.4, DEF is mapped to 8.6, ZXC is mapped to 5.7, and QWE is mapped to 9.5. And note that these keys are not ordered, nor are the values. So as you can see, QWE comes after ZXC, even though QWE comes before alphabetically, because HashMap doesn't order the mappings. Now let's use some of the other methods of HashMap. So first, map1.size. And this should print 5, because there's 5 mappings, 5 different keys. So then now let's do get. So map1.get, say ABC, and that would print 1.2 as shown below. And if I try to get a value that doesn't exist, say AB, then it'll print null as shown below. There's also contains keys, so if I do map1.contains key of say DEF, that would be true. However, if I do map1.remove DEF, then DEF is now removed. So now when I print the map, it would only contain 4 mappings. And now when I do map1.contains key DEF, it would be false because although DEF was originally mapped to something, now it isn't. Now next, contains value. .7 would be true. However, contains value of say 8.6 after DEF is removed would be false, as shown below. And then next, put if absent. So then map1.put if absent. If I try that on ABC and 3.4, that wouldn't do anything, as shown below. ABC is still 1.2. However, if I do map1.put if absent on say ABD 3.4, then I print map1, then it'll have ABD mapped to 3.4. And note that when I do map1.size now, it's 5 because there's 5 keys, even though there's only 4 different values. Next, if we do map1.remove and then say ABD, 4.5, that wouldn't do anything to the map because ABD is not mapped to 4.5, as shown below. However, if I do map1.remove ABD, 3.4, then I print the map, then it would remove the association from ABD to 3.4 as shown below. And then the replace method, so if I do map1.replace ABD, 8.9, it wouldn't do anything to the map because ABD is not inside the map right now. It's not a key of the map. However, if I do map1.replace ABC, 5.7, and then now I print the map, then now ABC is mapped to 5.7 as shown below. Now, currently we can print the map, but we have no way to loop through the elements. One way to loop through the elements is to use the entry set method. So set of map.entry of string, double entries equals map1.entry set. So if we print the set right here, we'll see that it just contains a bunch of entries as shown below. And now, what does an entry do? Well, if we loop through the entries, so if we do for map.entry of string, double in entries, then I can print, for example, e.getKey and e.getValue. And that would be an example of how I run through and print the associations without their formatting. There's another way of looping through a map. So we could also do set of string keys equals map1.keySet. And keySet returns a set of the keys. So now if I print keys, it would look like the following, just a set of string like as shown below. And now if I loop through the keys, we have access to all the keys. So when I print S inside the loop, I can print all the keys. Now, however, we still haven't looped through the map, we just looped through the keys. So how do I access the value as well? Well, I can just do map1.get S. And now it's the exact same thing as the code above, as shown below. Finally, map1 has a values method in addition to the entry set and the key set method. So collection of double values equals map1.values. Then when I print values, for example, then it would print the values. And note that the values method allows duplicates because this is a collection, not a set. So duplicate values are included in here. So when I go through all the values, and print them, I can get the following. Note that using the values method is not a way to traverse through the entire map because there's no way to get the keys from just the values. The two ways to traverse through a map or go through every single mapping would be to just get every single mapping or every single entry as shown in this block of code, or to get every single key and access the value through the key as shown in this block of code. Now, what is a set? Well, set is an interface that HashSet and TreeSet implement, and it satisfies that there's no duplicate elements. And what is a collection? Well, collection is an interface that many things implement, including ArrayList, linked list, HashSet, TreeSet. All of these implement the collection interface. And all collections satisfy the property that you can loop through them. And sets, so far we've only learned that HashSet and TreeSet are sets. Here's an exercise. Create a method that takes an array list of string and returns a hash map containing mappings of the following. The element of the list mapped to the number of occurrences of that element. So for example, if we have QWE, ABC, and QWE in the list, then we map QWE to 2 and ABC to 1. So first we need a method, so public static, and then we need to return a hash map of string getting mapped to integer. And let's call it occurrences, and let's take as input an array list of string. Then of course we need a hash map to return. And then now we just loop through the list. And now there's two cases. One is that S is already a key of the map. If that's the case, so if map.contains key S, then all I have to do is increment what S is mapped to. So how do I do that? Well, map.put S, and so now we want to map S to what it was mapped to plus 1. So map.get S plus 1, which increments what S is mapped to by 1. Then otherwise, I just do map.put S comma 1. Now notice that this logic wouldn't apply because S isn't mapped to anything. So I would need to make a new mapping S to 1. And now all I have to do is return map. So now let's call the method. So first let's create an array list of string. And then let's just add a few elements. And then let's just call occurrences. So let's store that in a hash map. And now when we print OCC, we get that ABC is mapped to 1 and QWE is mapped to 2, which is what we want. Now let's look at our rectangle class we had a few classes ago. And now let's first comment out our equals and hash code methods for a bit. So now, first of all, if we go back and construct a hash map of, say, integer to rectangle, say QWERTY equals new hash map of integer to rectangle. Then let's just put some mappings in there. Then I print the map. Then afterward, I print the map, and it looks like this. Works perfectly normal. Note that duplicate values are allowed, but duplicate keys are not allowed. And the reason this works normally, even though I don't have the equals and hash code method, is because, well, we don't need to check the values for duplicates because, well, HashMap allows for duplicate values. It doesn't allow for duplicate keys. And we don't need the hash code method either because, well, the rectangle is the value and we store things by keys. So there's no problem there. Now let's take a look at hash map of rectangle to integer. And then let's put the mappings in reverse. And now let's print this map. And now we see that we have certain problems. First of all, we have this 5x7 rectangle and that 5x7 rectangle, which means we have duplicate keys, which is not good. Second of all, if we try to do query2.contains key of, say, new rectangle 47, it would output, well, false, because we didn't implement the equals method. So that's not good, because rectangle is the key, and since we don't have the hash code method either, it's stored awkwardly as well. So to fix this, we need the equals method and the hash code method. Then after that, the map is fixed. So just note that when we have our rectangle class or some class that you create as the value in a map, then you don't need the hash code method at all, and you don't need the equals method unless you're using the contains value method in the map. However, if your rectangle or your other class is the key, then you definitely need both the hash code and the equals method. Otherwise, the hash map won't work properly. Another type of map in Java is a tree map. A map with its mappings ordered by the key. So, for example, tree map of string, comma, rectangle, and then tree map 1 equals new tree map of string to rectangle, for example, and tree map 1 dot put QWE comma, just put some elements into here. ASD to 4x7 rectangle. And then ZXC to 5x7 rectangle. And say QWE again to a 4x7 rectangle. And then I print the map. And as shown below, first ASD, then QWE, then ZXC, as ordered by natural string order. And note that rectangle doesn't implement comparable, but we don't need that because everything is sorted by the key, not the value. Now, trouble comes if I try to do tree map of, say, rectangle, comma, string. Because then if I try to insert a mapping, then it wouldn't work at all. It would cause an error because rectangle has no good ordering. So you just have to remember with TreeMap, only the key has to be well ordered. The value does not have to be well ordered in TreeMap, just similar to how the value does not have to have a hash code method in HashMap. TreeMap has the same methods as HashMap, although it has other methods that you can see through the Java documentation API over here. So java.util.treemap, and you can see all the methods over here in their descriptions. Or you can just find TreeMap directly through this list of classes in the Java library. Now, currently, we've learned about array list, and there's hash set, tree set, hash map, tree map. So first, array list, it's an array that can grow or shrink in size, adding to the end or removing from the end is fast. Accessing the elements at an index is fast. However, adding or removing from the beginning or middle is slow, and there can be duplicates. For hash set, it's basically adding and removing is fast, and checking whether an element is in the set is fast. And however, there is no such thing as accessing an element by index, so that doesn't exist in hash set. And then tree set, so then this is elements are ordered, and like hash set, elements, there's no duplicate elements. And note that tree set requires the elements to have a good ordering rule. So like the type must implement comparable, or you must have a comparator. And tree set is slower than hash set. Now HashMap, similar, has the advantages of hash set. And is basically a bunch of mappings stored by key, no duplicate keys. And TreeMap has the advantages of tree set, which is basically elements or mappings are ordered by key, which means also no duplicate keys. And that's everything related to various data structures in Java we've learned so far in this course.